I will continue to this Storm part, and I will be talking how Storm exactly enhances RGB and Lightning, and how it unlocks ability to build decentralized applications and DeFi things. DeFi things stands for Bitcoin finance. So what DeFi includes is such stuff as algorithmic stablecoins, decentralized exchange functionality, liquidity pools based on programmable assets, digital identities, DAOs, and Lightning Network. And it starts with the Bifrost, which is the generalization of the Lightning Network. And Bifrost is the thing that is run by LNP node. So LNP node is able to work with a legacy Bolt Lightning Network. So I will be calling it Bolt-based Lightning Network. And it also supports a new version of Lightning Network called Bifrost. And it can be used for working with both of these worlds. How Bifrost differs from the Lightning Network defined in bolts? Well, in many ways. Primarily, it was created to bring native Taproot and miniscript support to the Lightning Network, and also to let Lightning Network work with RGB assets. The thing with the bolts that RGB requires stop return commitments added to Bitcoin transactions, and we had to modify the structure of the commitment transaction in order to achieve that. And that actually was the initial incentive we had to do this Bifrost story. However, since we were already designing a new protocol, we decided to do it as powerful as we can to unlock other things which can be possible with RGB and Lightning. So this Bifrost is already will be ready for L2 if Bitcoin will ever soft fork to it. It supports channel factories and multi-peer channels. It, not multiplier, multi-peer, it's all autocorrection. It allows you to compose one channels on top of others, such that if you have a channel factory, you can create channels, other factories out of one factory with a smaller amount of participants, and then individual channels. Or you, for instance, can create DLC channels and add them to existing channel. So the channels are composable on top of each other. It also simplifies creation of layer 3 apps, and the Storm is one of these first layer 3 apps created on top of Bifrost. And it provides a native messaging without congestion problems of the Lightning Network, and I will be talking about that in a moment. So we have this nice stack we are developing the last 3 years, which starts with a P2P layer or networking layer, providing end-to-end encryption, on top of which Bitcoin protocol and Bitcoin blockchain operates. On top of that, we have RGB smart contracts. On top of them, we have Lightning channels. And on top of that, we have a custom up-level channels, which can do things like RGB, DLC, discrete log contracts, and Storm long-term storage. So this Storm, this first application on top of Bifrost. The Storm is the protocol for and network for decentralized messaging and storage. And the technology, the whole protocols that are related to peer-to-peer network that is used by Storm is this one. So we've, of course, reusing TCP/IP layer. But what we do is that we allow to use any, not just allow, we suggest to use one of the existing anonymization mixed networks or IPsec connections, which provide anonymity for the network traffic. Next, we have end-to-end encryption done with a Bolt 8. The Bolt 8 is the part of the Lightning Network standards, which uses noise XK to do end-to-end encrypted traffic between Lightning nodes. We have modified the Bolt 8 to a different version, native Bolt 8 encryption protocol called Brontit. We did a protocol called Brontosaur, which extended the packet size from 64 kilobytes into up to 16 megabytes. And that was very important for many applications that can use Lightning Network. For instance, discrete log contracts, they do create signatures for different outcomes of the oracle, and these signatures takes many megabytes in size. And the really big challenge of getting DLC working over the existing Lightning Network because of the size limit, which we removed with this modification. On top of that, we have a Bifrost peer-to-peer network that provides a general abstracted protocol for channel management and messaging in the Lightning Network. And we use that to create a Storm peer-to-peer level, which does transfer of arbitrary messages and data. And then there are specific Storm applications that utilize all the stack underneath. And I already demonstrated just 5 minutes ago the file transfer and chat functionality. And the same way it is used by RGB to do transfers from one node to another of RGB payments, or to publish information about issued RGB contracts and assets. There are much more with the Storm that can be done with the Storm, like decentralized exchange, and I will come to that in a moment. I will, as I said already, in existing Lightning Network, Bolt Lightning, it is impossible to transfer files or large messages. I already described why it's impossible for large messages, but quite a common question, why you can't split a file or a large message into smaller packs and just do a multiple packs transfer through the Lightning Network? Well, it doesn't work that way. And why it doesn't work is because the way messaging works in the Lightning Bolt Lightning Network. First of all, there is no message standard for Bolt Lightning Network, which is merged to the core specifications. It's still a work in progress, so probably it may change in the future. However, the principal restriction of the Lightning Network that it always sent information from one node to another node by using onion routing. And this onion routing is basically tries to reinvent Tor network or mixed network in the context of Lightning Network, which for my opinion is not very efficient, and actually that creates a lot of problems where it's really hard to pass a lot of information through Lightning Network messaging, because it will congest a lot of bandwidth. The way this routing works is that if you'd like to send a message from Alice to Bob, you need to encode in onion way the message and pass it through all the nodes in the Lightning Network, which has channels between them, which makes sense and was originally created for support Lightning routed payments. You need to route the payments, so you need to pass through the nodes that have channels. However, it's meaningless if you send messages which are not specific to the channel and that which not require channel functionality. For instance, if you run chat, you don't need to pass the payment through all the nodes that are connected with the channels. At the same time, Lightning Network disencourage direct connections between the nodes in the network. And that's end up that whenever you want to send a message from Alice to Bob, you consume traffic of at least of multiple connections between nodes. And you have a lot of restrictions, so you can't run a real scalable application on top of Lightning this way. The second problem is that these intermediary nodes are allowed to drop the packets. So they may not forward the packet. The only thing that makes them forwarding the packets is the economic incentivization. And it works well with the payments because they earn a small fee. However, they do not earn the fee for forwarding non-payment messages. And that's why Lightning nodes in reality will be dropping packets, and it will be really hard to get Alice sending Bob a large file, since arbitrary chunks will arrive in arbitrary order and some of them may be dropped. So this all the restrictions, packet size restrictions, and an ability to split into multiple packets because of the droppings, an ability to directly connect, and the need to congest a lot of inter-node connectivity. And this all makes impossible to practically do applications. We have, for instance, Sphinx chat, but the problems with the Sphinx chat is that you will face all these problems there. If you try to use it, you will see that this actually doesn't really works as expected in the practice. So dApps, this makes dApps impossible with existing Lightning Bolt-based network. All these beautiful things that can be done, like chat, file sharing, social networks, DLCs, decentralized storage, or search on top of Lightning with bolts are not possible. And that's why we still don't see these applications being created for the Lightning Network. How Bifrost fixes that? Here, let's assume we have 3 nodes that support Bifrost. We show them with the green. They still part of the same Lightning network, and there might be other nodes which do not support Bifrost. We show them in yellow here. And these 2 networks still able to interoperate. Whenever Alice needs to send Bob a message, the thing that Alice does is this. That's simple. So it doesn't need to account into which channel do exist or not. If the Alice would like to attach a payment for this message, for instance, she would like to pay Bob for some query or make Bob read the message by incentivizing him with a payment, she still can create the routed payment, but it will run independently the way it does usually with the routing payments in Lightning Network. But the important part that it is not required to be done for each of the message and communications between Alice and Bob. So we can significantly increase the bandwidth. And the communication can go both ways directly without establishing a channel between Alice and Bob. I don't know why we have a repetition of this file. Now, another situation when the Bob is behind the NAT NAT, and for instance, Alice can't connect to Bob directly. And that's where Lightning onion routing comes useful. However, still, you don't need to route through all the nodes in between. What you can do with the Bifrost is to find the node supporting Bifrost in the network as close to Bob as possible. It doesn't need to be directly connected to Bob, and use a small onion routing to get this message to Bob via Bolt-based Lightning network. After that, Bob will be able to connect back to Alice. It's kind of pinholing of the NAT. And this can work even in a more complex setup with both Alice and Bob behind NAT. And here Alice will connect the same node. However, this node will run the same connection to Bob, but the instructions in the message will tell Bob to connect to Alice through the node E. And the messaging now will be routed through another node, but only one of these nodes. And again, it doesn't require to establish new Lightning channels. So that's the way how the Bifrost messaging is working. And this enables decentralized applications. We don't have packet drops now. We have efficient NAT bypassing, and the packet size is increased up to 16 megabytes. So basically, any app transaction, for instance, it could be an RGB transactions or any other kind of transactions, can be packed into a single message. And if this packet is dropped, there is still a way how the app can easily handle and resend that specific drop packet, and it wouldn't break the transaction structure. So what we had today in the demo, where the data were going from one node to another. Unfortunately, I wasn't able to do this RGB part because I didn't manage to get connection between RGB node and the command line client, but I was able to do this part. And that's what actually happened. Whenever I was sending a chat message or doing a file transfer, the instruction went to the storm node. It worked with the local storage, with the local database, and then sent through the Lightning network, through the Bifrost to the different storm node. And when a file was sent, it initially sent a header of the container listing all the chunks, and only the chunks which are needed were requested from here to here and then saved locally, such that they can be retrieved by a remote peer. So that's what actually was happening in the demo. not exiting, it was exciting Storm. Sorry for the typo. So exciting Storm allows us to do a chatting end-to-end encrypted based on Lightning node pub keys as identifiers. It allows to do a file sharing network, also end-to-end encrypted, which distinguishes it from torrent. It also can be used to run this distributed trustless data backups. And one day, probably, it could be used for building a social networks. For Bitcoin wallets and Lightning nodes, there are also advantages that can be taken from adopting Storm. First of all, you can now back up wallet descriptors in encrypted form. And you can back up channel state. So again, you don't need to think about creating another cloud solution for that, and you can use decentralized network to do that. You can have a database of your wallet, keeping some transaction meta information. For instance, you can annotate your payments, and you can sync this database across multiple devices, again, using Storm functionality. And finally, and probably most important, Storm gives much more monetization for Lightning nodes. They can operate now as a decentralized storage providers, taking fee for that. They can operate as a search engines, kind of decentralized Google, create indexes and be paid per request to that indexes. That's the way how we intend to run information about RGB smart contracts and assets, such that asset issuers will be able to publish it into the Storm network and pay small fees to the nodes which keep this information, such that other who are interested in the contracts, wallets, users, exchanges will be able to download it from that nodes. And finally, a Lightning node would be able to operate as a decentralized exchange and get the fees for the exchange. And that can be useful alone, but also the DEX part is very important for the routed RGB payments over the Lightning, where you don't have a sufficient liquidity over the route, so you will be doing exchange on certain stages of the payment. With RGB specifically, Storm is used for sending RGB consignments, and wallet developers would need to spend less efforts on integrating RGB. As I just described, it can be used for publishing and searching information about RGB contracts and assets. And it is an important component of algorithmic stablecoin design, which we will be doing later this year, and DeFi, because basically Storm provides a global state database for RGB. That's a long discussion we had that RGB doesn't have a global state. Yes, indeed, that is true. It doesn't have a global state because it doesn't need it. The global state is achieved by reutilizing Storm on top of the Lightning network. This also can be used to do an order book-less DEX functionality, because now nodes do not need to publish all the exchange rates that they are running. They already publish into the Lightning network information about the assets. They have channels in, so nothing has to be changed there. And a person who would like to do a decentralized exchange over the route, the only thing is needed is to directly connect to those nodes through the Storm and ask them for the exchange rate, and then construct the route you'd like to use. So that's how DEX will be working with RGB and Lightning network. Also, you can create order books if you need for things like cross-asset discrete log contracts or atomic swaps. Again, useful for RGB. You can take RGB21 schema, which we will be releasing in this autumn, and it's an NFT schema, and you can build a digital media distribution network with that using Storm functionality, since you now have a way to store the media files, audio recordings, books, videos, images in the decentralized storage network of Storm and pay for that storage. And finally, you can wrap GPG-based identities into RGB smart contract and reuse Storm to build a web of trust, to relaunch web of trust, solving the problem with the key servers. Now, instead of key servers, a Storm network can be used. So it's all brings something that we can call for, like some scammers, like we can call it a Web 4. And future applications of developers who are interested in that may include things like a decentralized Google paid in Satoshis, and not paid by tracking users and by advertisers, but instead paid per request, which will solve the problem of privacy, at least partially. Again, it's better than torrent and IPFS because it has payments in Satoshis embedded. And unlike Filecoin and Storage and other projects, without introduction of any new shitcoins. And nothing probably prevents you from building new decentralized social networks or GitHub-like functionality by reutilizing the Storm protocol. So Storm unlocks Bitcoin decentralized upworld and returns the need to keep only 12 words, taking care of the rest. And this signifies the change we were working on for the last 3 years. Probably those of you who participate in our dev calls for a long time remember that additionally to RGB development, we had that vision that RGB will enable smart contracts, but we will also build an Internet 2 thing using Lightning Network and improvements in the networking protocols that will bring more censorship resistance, privacy, and scalability to the world of Bitcoin and Lightning Network. So here we can summarize that actually we are really close to this goal, and all foundation levels are there. And this stack is ready for end user developers to do their own application. Potentially, for instance, a Nostr protocol can integrate and it can run on top of the Storm and Bifrost. And by doing that, it can be able to do the data storage in decentralized way. So this Internet 2 stack, comparing to Internet 1, does the following. We reuse the TCP/IP part, nothing changes there, but instead of SSL TLS encryption that requires centralized authorities, we recommend to use Tor, NIM, or IP, I2P mixed networks, and use a Brontit or Brontosaur, which is extended version up to 16 megabytes for authenticity and end-to-end encryption. So all the Internet 2 applications now can use end-to-end encryption at the transport level and session level, session level. On top of that, you have a Bifrost P2P network, on top of which you can create multiple applications like I was showing with the Storm, chats, file transfer today. And also there is a protocols called Serapis, which are not for P2P connection, but for client-server communications, which I wouldn't be covering today. So that's all of the stack. And that's the vision we had at the beginning of our work 3 years ago, finally brought to the life. And the only thing I really regret that I wasn't able to show the transfer of the RGB assets due to the issues with the connectivity, but I hope that I will be able to do that on the next demo and do that together with showing graphical user interface, which will simplify understanding of what's happening there. Because right now, to do the transfer of the asset, you have to do at least 6 or 7 command line commands, distant commands, and that's really complex task to even repeat if you have a screen recording. So with a high level integration and wallet, that will allow you as a users to test and play with RGB assets, and that would be what we will be doing in next demo. Probably we can go to the questions if there are any.
Sure. Thank you for the presentation and for the demo still. Like one of the comments says, wow, I've been away for a year, so much happened in the RGB ecosystem. So that's a good thing. Hunter has a couple of questions. So the first one is, what about encryption at rest? Should consignments be encrypted?
So there are different, when we talk about encryption, there are two different things. All the communications are encrypted such that man in the middle is not able to listen to the data communication, so it's not even changeable. But when you send a consignment from one node to other, of course, the sender and receiver, they will see the whole source data. Now it is the question, do you want to encrypt those data? Well, the idea is that the data are, I probably go back to slides, so I will get screen sharing. The idea is that you send consignment directly to the user who is a beneficiary of the payment. And even if you send this consignment through intermediary peer in this schema, you have an onion packet that prevents peer E from seeing the consignment data. The only moment when you would like to, when you will send the consignment not to the beneficiary, is when this beneficiary doesn't have a node online. It doesn't have Lightning node and RGB node. Well, main is the Lightning node. If he has the Lightning node, he will be able to accept the consignment. But if the beneficiary doesn't have Lightning node 100% online, there are several things that beneficiary can do. First of all, it can specify a trusted node which will receive unencrypted consignment. However, in the future, we plan to add ability to send consignment in encrypted form to a non-trusted node, and then the beneficiary will be able to download it from there. The only disadvantage of doing that is that you can't leverage the torrent-like data transfer, because if you encrypt the consignment, you can't maintain the list of the state transitions, historical state transitions, which are already known to the end user. So the end user and the storage will, and the sender will have to upload the whole data package to the intermediary node. And in this case, the data package can be encrypted, and it's basically will be defined by a protocol, dedicated protocol, and it wouldn't require changes to RGB node or Lightning node. It will be just a wallet level protocol of the encryption between these two peers.
I guess Hunter was referring also like if we should encrypt data, encrypt consignment data when they are stored in the device in case of data breach, I guess.
Well, in this case, it's not even a question of any of these protocols. It's just up to the wallet developers to do the data encryption.
Yeah. So but like the RGB node doesn't do any encryption by default in the storage.
RGB node uses it doesn't do even the storage itself. It connects to the database, and the database provider just uses certain API. You can do another different database provider which will do the encryption. So you don't need to modify RGB node. So everything is modular. If you remember in the demo, I was doing this store daemon, and this is the daemon that is used, but you can create another daemon because it's daemon very simple. It's just a wrapper around the database, exposing the database to the network API, client server API.
It's also like the store daemon doesn't do encryption.
Right now doesn't, but you can add it to it, or by forking it, or you can do just another daemon, JavaScript, anything, and it will work.
Okay. Thank you.
Okay. Thanks. The second question from Hunter is the current RGB20 implementation in 0.8 already in Illuvium? Is it using Contractum?
Okay, I will try to answer one. It's actually two questions. So the Contractum part is simple. No, it doesn't. And it wouldn't, because Contractum is the language to write the smart contract. So once you write the smart contract and compile it, actually not even a contract, but a schema for the contract. So only schema developers will be using it, and you can do your own language or use assembly language or do it with a contractum. It's not a part of the consensus at all. So contractum is not finished, but even when it will be finished, like it wouldn't be the only way to write the contract, and it's not part of the consensus layer. Regarding the second part, is RGB20 schema uses the Alluvium? The funny fact is that RGB schema is not yet released, and it will be released only on the next call, because it exists on top of the RGB node and so on. And there are funny things we would like to improve in the RGB20 schema, which are related to Alluvium. For instance, because now we have abstract concept of contract state. As you remember, last demo I was showing you, like you can ask the RGB node on the state of certain contract, and you get this JSON structure with the fields. And RGB20 just interprets some of these fields. Previously in RGB20, it's like asset name and asset description and ticker and denomination, they all were defined with a metadata. But also there was a way how this metadata can be changed and updated by the issuer by doing a special type of state transition. However, with the introduction of Alluvium, metadata can't be used anymore to store the state. The only way metadata can work is to provide some context information to the verification of specific state transition. But they can't represent the state of the whole smart contract. So we have to move the ticker, and if we would like to maintain the ability for the issuers to change and rename the asset or change the denomination of the asset, we will have to move this data from the metadata to the proper state. So they will be bound to a definite seals and updated with the closing the seals over a new name and message. So this part is not yet released, and this will be released the next week, after which we can say that the RGB20 schema is completed, and yes, it will be using the, all the new things that are coming with Alluvium. However, we do not rewrite in Alluvium the existing validation of RGB assets, and it is using embedded procedure just because of the security considerations, because we didn't spend enough time debugging the Alluvium, and these RGB20 things will be using embedded procedure forever, which is a part of RGB node. And this embedded procedure is not RGB20 specific. It will validate any homomorphic encrypted data with a bulletproofs and Pedersen commitments. So basically, even Alluvium will reutilize this embedded procedure, which is part, basically will become a part of the consensus layer. Was I able to answer the question?
Yeah, Hunter wrote that it makes sense. So yeah, thank you for the answer. I actually have a couple of questions too. So the first one would be regarding the search engine that you mentioned, which can be possible with the Storm now. So do I understand correctly that we would be able to search for only like Bitcoin, RGB, Lightning related stuff there? Not
No,
for...
no, no, no. No, it's the search can be an application on top of Storm, because Storm is opened for new applications, so anybody can develop his own solution. So I did a simple file transfer in chat application. Somebody may do a different chat applications working differently, and the same with the search. Any developer can develop something related to the search such that it indexes some data and return responses on this data, leveraging Lightning payments and the rest of the story. What specifically can be done with that? Well, whatever the developer would like to. He can index some Lightning Network data or RGB contracts. For instance, we will be doing a service that will be registered indexing RGB contracts for Lightning nodes, such they can provide for the network provide to the network information about the contract. Somebody would like to do a decentralized Google and they will index the internet. I don't know how specifically that can be done, but basically you have a powerful API, and as a developer, you can think about the proper design. You have all building components, and so basically it's just it's huge effort to do such a decentralized search, but you have all the building blocks for that.
Okay, great. And regarding the information on the RGB contracts, do I understand correctly that we would be able to find only the information that was published, right? That was revealed to the network from the RGB contracts?
Correct. Absolutely.
Because if you don't want to publish it, no one will ever look for it. I mean, even if they look for it, they will never find it, right?
Well, if somebody published the private information and somebody stored it, of course it can be retrieved. But the protocol, the way protocol works, it prevents such things from happening by default if you don't specifically disclose your data.
Yeah, exactly. Okay, great. And last question, you mentioned Nostr. Have you like researched what the guys are doing and how exactly maybe they can be integrated into what we're doing, or the other way around?
I really didn't research it. I looked at it briefly, and from what I saw, it seems that it's a perfect fit. So what you can do is basically Nostr doesn't provide you with the storage, client server side storage, as far as I remember, and that's what Storm is doing. This is exactly what Storm is doing, and I think that can be.
So, Maxim, I did look did a little bit. I think it does it does offer some kind of data viability using this two-tier system where you select these basically let's call them master nodes. The point is that it's not incentivized. So far, I think it just relies of some kind of altruistic redistribution of the encrypted content that could not scale with several users. So I think that at least one of the web client I was using a few weeks ago had some external node backing up the content for me, so I could just disconnect and reconnect. But it was not incentivized or anyway structured in order to scale up. So I think the good fit may be to apply the incentivization logic to the same maybe security authorization UX expertise that Nostr is developing since a while.
Yeah, probably. So I'm not. I didn't have time to look into this all deeply, but I have a feeling that there is things that can be useful to each of the protocols if they integrate in some way.
Yeah, it's great because I was actually thinking about sending some information on our work to the Nostr guys.
Mm-hmm.
This is very helpful. I think they would be interested in looking into it. Thanks. I don't have any questions left. Guys, if you have any questions, feel free to just speak up or send them into the chat here.
So hopefully next week we will go through the whole process of operating with RGB assets now, utilizing all this power of Bifrost, Storm, and the nodes. Sorry for not showing that today, and thank you everybody for joining.
I wanted to ask you, like, maybe if you figure out how to fix the demo issue, like quickly, that was like a simple problem. Maybe can you just share the list of commands that you will go through the demo, so we can already start trying it before next week?
Yeah, I think that makes sense. So I will be just writing them down and sharing. Yeah,
that will be very helpful.
Yeah.
Thank you.
There's another question also. Can an RGB token be burned so it does not have any value outside of the contract, thus prevent trading of the token? And can the can the contract then still be functional?
Well, the token for sure can be burned, and but I'm not sure that I understand the rest of the question. So you can write a RGB20 tokens. All RGB20 tokens can be burned or burnt and replaced if the issuer opts in for that. And the burning of a single token doesn't burn the contract. Maybe it's because it's not working like in Ethereum. In Ethereum, you can fuck up the contract and it's stopped. In RGB, there is no way of stopping the contract. You can't do something like destroy on the contract like what's done with this infamous hack of the Polkadot ICO contract. In RGB, the contract doesn't exist on blockchain at all. And the contract is distributed always, and the state of each individual output is separate from all other states, all other output state, and you always update them one by one. So if you burn one output, the rest remain untouched. So that's probably the best way of responding to it.
Mm-hmm. Yeah, okay, great. Thanks. Yeah, so far I think that's enough of an answer. Any more questions, guys? Yes, Perry?
What's that?
Perry, speak up.
In the meantime, Maxim, that noise was just people using the clap emoticon that now produces clapping noise. No problem.
Yeah, this is stand innovation. Stand innovation.
I see.
Perry, did you have a question? You raised your hand. Can you type it somewhere, or you don't have it anymore?
No, sorry, I pushed the wrong button.
Ah, okay. Good. Okay. Any other questions? Probably if you don't have any questions, we can wrap this up for today and look forward for the next call. As always, all the recordings will be uploaded into our YouTube channel and GitHub repos, so stay tuned. Everything will be online. Maxim, thank you very much for the presentation. I think it's like one of the best ones, regardless the problems that we faced during the demonstration of the RGB node.
As always. Okay, thank you.
Yeah, it's like it always happens, so I think everyone's cool with that. Thank you guys for being with us. Much more people that we usually have that we could have expected. So thanks. You know where to find us if you have any questions. And have a good day, night, good morning. Take care.
Bye-bye.
Thank you, everybody. Bye. Speak soon.
Bye, guys.
Bye.
Bye.
Bye.